Hello viewers, moving on to the next question from Power Electronics that have came in GATE 2026 Electrical Engineering. Question number 28 according to the master question paper. So 1 mark MCQ type is as follows. It is related to MOSFET circuit basically. Consider the circuit shown in figure A. A gate pulse Vg is applied between time instants t0 and t1. After t1, during the MOSFET turn-on process, it experiences a voltage overshoot. Okay, circuit is given as this. This is a gate circuit, VDS, and diode is connected. So RF is there, and the characteristic is given as like this. Okay, VDS. Right, as you can see. So based on the VDS waveforms shown in figure B, which one of the following options is correct? You identify the order of the resistances for the characteristics. Okay. Moving on to solution, let's discuss the analyzing the circuit first. सर्किट एनालिसिस बहुत जरूरी है इस क्वेश्चन में, तो पहले वो कर लेते हैं, है ना. सर्किट एनालिसिस में क्या करना है? लेट्स फर्स्ट एनालाइज द टाइम फ्रॉम time when the gate pulse is applied, that is T0 to T1. As the gate pulse is applied between T0 to T1, gate pulse is 15 volt, what happens is the MOSFET behaves as a closed switch. Okay, so this closes, right? Okay, and the inductor starts charging through this path. Okay, right, starts charging through this path, and basically this behaves as a closed switch, the MOSFET, and there is linear charge such that VL, the voltage across this inductor VL equal to, as the MOSFET behaves as a closed switch, this is short basically, so this is the ground voltage, so VL equal to VDC, and VL is, as we all know, is LDI by dt. IL से ठीक है, तो ये वाला पाथ फॉलो होता है जब MOSFET closed, between time instants T0 and T1. Now after T1, when the gate voltage is withdrawn, the gate pulse is removed, so the inductor starts discharging. Okay, and the MOSFET behaves as an open switch. Open switch means this inductor current will have no other path, it will circulate in this loop, right? जब ये हटा दिया जाए T1 के बाद, तो ये लूप में सर्कुलेट करता रहेगा इंडक्टर करंट, इट विल कंटिन्यू सर्कुलेट इन द लूप. ओके, to the resistor RF and the diode D, it will discharge the inductor L. So the initial voltage spike in VDS will be what? VDS T1. This spike. This is a function of this RF actually. VDS T1 can be written as VDC minus VLT1. VDS is what? We apply KVL. VL plus VDS equal to VDC. So VDS will be what? Capital VDC minus VL. So capital VDC minus VL T1. VDC is constant, so it is not a function of time. At T1 also it will be T1, and in another instant it will be VDC only. So VL T1 is what? Suppose at T1 the current flowing through the inductor was IL T1. Now VL T1 will be what? This current flowing in this direction. So this is the voltage drop will be, diode will be short, voltage drop will be this. So VL T1 will be what? VDC minus VL T1 will be what? Minus IL T1 into RF. So minus IL T1 times RF. समझ आ रहा है? I hope it is clear. right? So it will basically what? VDC plus ILT1 into RF. What? VDS-T1. This is voltage spike. Just after this gate pulse is removed at T1, there will be a voltage spike in VDS, and that will be equal to VDC plus ILT1 into RF. Okay. I explained the polarity. While will be minus here. Because the current will flow in the reverse direction while discharging, opposite direction में flow करेगा, तो ऐसा होगा. तो ये क्या होगा? Higher the value of RF, higher will be the voltage spike. Higher the voltage spike. Right. So highest voltage spike you can see for R1. Okay. Highest voltage spike is for R1. Then for R3, as you can see. Then R1, R2. So highest voltage spike will be for the highest resistance. Okay. Followed by the intermediate one and then the lowest. So R1 is greater than R3, greater than R2. Option B, correct. And another way of analyzing, extending the analysis further, we can also say that from the time constant, rate of decay. Now, time constant for this is what? RL circuit, series RL circuit basically. Series RL discharging circuit. Time constant for an RL circuit is given by what? Tau discharging equal to L upon L is constant fixed RF. So it is inversely proportional to RF. That is, higher this value of RF, lower the time constant. Right? Okay. Lower time constant means fast discharging. A circuit has very less time constant means what? It will discharge or charge very fast. So higher the resistance R1, highest. So its rate of time constant will be lowest. So rate of discharging will be fastest rate. As you can see, this discharges very fast. After that followed by R3. R3 is less than R1. So tau, the time constant will be higher. So discharging will be slower than as compared to this R1. And for R2 it is the time constant will be what? Highest time constant means what? The circuit is discharging takes place at the slowest pace among the three, comparing the three. So tau R1 less than tau R2 less than tau R3. So this is the what? Fastest discharging. This is the slowest discharging. ठीक है? This is the order. R1 discharges the fastest. R1 discharges the fastest with RF equal to R1, and the discharging slowest with RF equal to R2. And the spike is highest with RF equal to R1 and lowest with RF equal to R2. So I have analyzed the entire working and of the circuit, MOSFET circuit in detail. When between T0 and T equal to T0 and T1, when the gate pulse is given to the MOSFET has a closed switch, inductor charges, then when the gate pulse is removed at T1, the inductor discharges through RF. So there is a voltage spike across the MOSFET. I have explained the steps of analysis steps also. Hope this solution is clear and comprehensible. Good question, good analytical question. Though of 1 mark only, but pretty good. Conceptually pretty good. If you still have doubts or queries, that's all for solution to this question. So please have any doubts or queries, please feel free to ask in the comments. And I hope the analytical solution will be helpful. So that's all for solution. Thank you.